Alright, in this video we're going to go over 8-4, angles of elevation and depression. Now an angle of elevation is simply you're looking up at something. Alright, if you're looking up, your eyes are elevated, so that's an angle of elevation. Angle of depression, you're looking down. So angle of depression, angle of depression, you're looking down. So if you're angle of depression, you're looking down at something, that's an angle of depression. Think about it, most people who are depressed, they kind of, dip their heads a little bit, so they're physically looking down. Or if you think a depression in a surface, alright, so it's looking down. So here's a little example of that. We got our little person here, really skinny. They kind of need to eat some food, a little anorexic looking. Alright, and here we have a hang glider. Yeah, that's supposed to be a hang glider. Alright, so we have a hang glider and we have our little person. If they're looking up at the hang glider at a 38-degree angle from the horizontal, alright, and that's important when you're dealing with angles of elevation and depression, it's always from the horizontal, alright. So, if they're looking up at the hang glider at an angle of 38 degrees above horizontal, that means since they're looking up, that's an angle of elevation. Alright? Now the hang glider looking down at the person, alright? Now, since she, I will say she, looks like they have long hair. If she's looking up at him at 38 degrees above horizontal, he would have to looking down at her at 38 degrees below horizontal. Alright, so these will be the same. Your angle of elevation and depression for two objects will be the same. Alright, she's looking up at 38 degrees, he's looking down at 38 degrees. Because if you think about it, these lines are parallel, so these are alternate interior angles, so they will always be the same. So since he's looking down, it's an angle of depression. Since she's looking up, it's an angle of elevation. Alright? Alright, so let's try to identify some angles of elevation and depression. Alright, so you're in this hot air balloon. Okay? As you can see, I'm not very good at drawing people. Alright, so you're in this hot air balloon. Say you're looking up at the bird. Obviously, I'm not good at drawing birds either. Alright, so you're looking up at the bird. Well, the key word there is up. Since you're looking up at the bird, that means this is an angle of elevation. Alright, because you're looking up at the bird. Now, if the bird looks down at you, alright, since he's looking down, alright, the bird is looking down, that means that is an angle of depression because he's looking down at you. So, angle of depression. Alright. Now, I'm going to give you a few moments. Figure out what 3 and 4 are. Are they elevation or are they depression? Alright, so figure out what 3 and 4 are. Take a couple seconds. Alright. Angle 3. You're in a hot air balloon. You're looking down at the person at the bottom of the mountain. Since you're looking down, alright, and so down, depression. Alright, since you're looking down, it is an angle of depression. Since this guy is looking up at you, that means it would be an angle of elevation. Alright, so put yourself here. Alright, if you look up, it's elevation. If you're in a hot air balloon and you look down at the hiker, that's depression. If you're in an air balloon and you look up to the bird, that's elevation. If you're the bird and you look down at the person in the hot air balloon, that's angle of depression. Alright? So if you think about elevation, airplanes, they fly at different elevations. Well, they're up in the sky. Okay, so that's elevation. If you think depression and down, because they both start with a D, okay, an angle of depression is when you're looking down. Alright? Now, how can we use this in the real world to actually solve things? Well, glad you asked, because here's an example. So, suppose you stand 5,300 feet from an airplane. Your angle of elevation to the airplane is 56.5 degrees. Your eye level is about 5.5 feet above the ground. How high is the airplane? Round your answer to the nearest foot. Alright, so as you can see here, we have a triangle. We have a known angle, we have a known side, and we have an unknown side. Alright, this ties heavily back to the previous section, 8.3, trigonometry. Because in relationship to this angle, what two sides are these? Hopefully you said this was the opposite side and this was the adjacent side. Alright? Now you have to ask yourself, which trig function deals with opposite and adjacent? Well, that's tangent. Alright? Because remember, tangent of your angle equals opposite over adjacent. That's an angle sign. So, the tangent of 56.5 degrees is going to equal x over 5,300. Now, of course, you multiply both sides by the 5,300. That cancels it out there. So, 5,300 times the tangent of 56.5 equals x. Alright, so x equals, just plug this into your calculator, and we're going to round to the nearest foot. It would be 8,007 feet. Alright, now granted we have found x, 8,007. We have found x, but we have not fully answered the problem. Because it says how high is the airplane? Well, for the height of the airplane, you need to take into account, alright, you need to take into account this distance as well. So what was that distance? Well, in the problem it says your eye level is 5.5 feet off the ground. So this is 5.5 feet. Alright, so the airplane, to find the height of the airplane, you have to take the 8,007 and add the 5.5 feet. So the airplane, rounded to the nearest foot, the airplane is actually 8,013 feet above the ground. Okay? So for angles of elevation and depression, well, mostly for elevation, well, some for depression, you have to take into account the distance. Like if it's a person, you have to take into account the distance from their eye level to the ground. Okay? So, don't forget to take into account this extra distance here. He could be looking down at a radar tower. This could be a radar tower, and the top of the radar tower could be, I don't know how tall radar towers are, could be 50 feet above the ground. Alright, so this would be the distance the airplane is from the top of the radar tower, and then this would be 50 feet. So you have to add these two distances together to get the height of the airplane. Alright, it doesn't, like I said, it doesn't have to be a person looking up. They could be looking down at something, and you have to take into account where they're looking at and how far that point is above the ground. Alright? So this all ties back into your trigonometry. So make sure you're strong on your trigonometry with the sine, the cosine, and the tangent. Remember, the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent, which is what we used here, is opposite over adjacent. All right? Because to solve all these problems using angles of elevation, you're probably going to use your trigonometry a lot. So make sure you're strong in your trigonometry. Okay? So this has been your angles of elevation and depression video. You can watch it as many times as you need to. Make sure you come to class tomorrow ready to work some problems. See you tomorrow.